All right. Administrative housekeeping out of the way. What did I say you need for materials in here?
Laptop.
You don't even need a laptop. In fact, let's put them away because there's like no reason until not even like a notebook, a pencil. If you have your own scientific calculator, I recommend it. If not, you might not be comfortable with the graphing calculators. I have some other scientifics that we can use in class if you're more comfortable with that. At the bare minimum, a notebook for our daily quizzes, and maybe you just write gigantic and you can't fit in this what you're supposed to be doing, well then you would just write on there, you know, page whatever, scratch work. And then you would have all your work labeled on that instead. So you need a notebook. A calculator is going to be good, but I can provide those if you need them. And this. That's it. You don't even get a textbook. Okay?
Do you maybe have an extra notebook?
I do have extra notebook. Is there anyone who just getting to a notebook is going to be an issue? Okay, I got a few. Okay, same. Womp. 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 Who else? Makes sense. There you go. You need one, what'd you say? You don't need it today.
Oh, today?
Yeah.
Yeah.
Okay. I just want to make sure that everyone's got one. All right, here we go. Send them on down. 1, 2, 3. I want you working together. Hmm? Can we have more than 2? Oh, yeah. Everyone got one? Y'all good? Okay. I want you to just flip through it real quick. Just kind of get a feel for what it looks like. Sorry that it's just a copy. All right, whenever I cover this up, that means I don't want the audio to actually go through on YouTube. This is just pirated material I stole from another district like years ago. So, shh, don't say anything. Okay. This is a curriculum that I taught out of that is specifically meant as an intervention packet curriculum for like summer school or right before Algebra 2. This is like all the stuff you absolutely had to know. Well, that makes it perfect for an Algebra 1 curriculum that brings it down to the bare bones of stuff we should know. And that's what this class is. I just want to get you your credit. I want you to not be stressed. I want you to learn some stuff or get better at some stuff from last year so that you can go to business math or geometry, get the credits, and get the fornication out of here, which is what a lot of you want, right? So that's the plan. If you flip through it, you'll notice that the majority of it is, well, yeah, that. It ain't pretty. But you'll notice it's example, practice, example, practice, example, practice. There's an awful lot of fill in the blank. That means this is simultaneously your notes and your assignment. No book, no extra handouts unless we need to do extra practice. This is it. This is everything. This one packet right here represents nearly the first quarter of what we're doing in this class. Okay, now, every now and then we're going to look at stuff and say, you know what, we just need an extra day of this. Maybe we need an extra week of this. Then I'll find other stuff and we'll supplement. That's what that folder and notebook are for. So you can toss stuff in there. Okay? But for the most part, we're just going to follow along in here. It's done catch and release style. I show you some stuff. We talk through some stuff, and then I say, all right, I want you to try these two. We go through them. I say, okay, you good? Now I want you to do these four, but I want you to do it without me holding your hand. And then we'll go to the next skill, back and forth, and back and forth, and back and forth, and back and forth. No, here's two examples. Now spend the next 45 minutes working on it. When instead y'all just look at each other and go, do you know what's going on? I don't know what's going on. Screw it, dude, geometry dash. Okay, I don't want that. It also means that we aren't going to have, hopefully, if things go right, you should never, ever have homework in my class. Never. I want you to do it in the room. You got a life outside the building. Go live it. Okay? If we get it done in class, which we usually will. We also don't have a set pace. So we just get done whatever we get done. Some days I'm going to say, y'all, I don't want you doing the work. No. Just don't start the assignment yet. We'll start the assignment in class next time you're in here. I just don't feel like we got far enough. That will be a common occurrence. So we all this ain't gonna be a big deal? Okay. Then, day one is almost more of a vocabulary thing than anything else. Where we're just gonna look at some math stuff and say, do I understand how this works? I hate new ones, how they smell funny. Like the long rope ones in here, they all smell like Fruit Loops. Oh. So, get it started. You notice there's going to be a lot of room off to the sides for you to write things. Write things. If I ever say, hey, you should write this down, you should probably write this down. Here we go. Round one, we're going to be talking about a bunch of different properties that make math tick. No, don't. Stop it, Frank. There we go. Oh, the smartboard's name is Frank. Many moons ago, I had you see how slow that was? Many moons ago, I had a young gentleman in my class by the name of Frank. Frank was in pre-algebra as a senior for the 4th year running. Needless to say, Frank was not the most intelligent or cooperative individual. Frank liked to put his head down on the desk and pretend the world didn't exist for the entire class, and then he was surprised when he showed up again next year. Henceforth, my board shall be known as Frank. Choices are made. We're going to start with commutative property. You notice everything's already here for you. The example, the words, the definitions. You say, I don't even need to write anything. Maybe you need to write a little bit of your own notes next to it to help you remember what's what. Like, commutative property says, come on, Frank, keep up. Order doesn't matter. The way that I always remembered it was the word commute right in there. Who thinks they live the furthest away from school? How far?
Basically almost Iron Creek.
I don't know where this is.
You don't know where Iron Creek is?
No.
How long of a drive is it?
That's like a
30 minutes. Haha, I would farther. 45 minutes. No.
yeah. What is?
Okay, A, I respect that because I wouldn't want to go to Newell or Bell either. 2 is one is. Yeah, you probably win. So for me, I live right outside of Bell because only rich people can live in Spearfish. I'm a teacher. I don't have the money to live in Spearfish. I live right outside of Bell. It's 11 miles, like door to door, from my house to the school. Does that mean that it's negative 11 miles from the school to my house?
No.
The order that I'm commuting does not matter. It's still 11 miles. There are two different commutative properties, and you should know that it is important that you have both of them. There's commutative of addition, commutative of multiplication. So the way that we're going to write those when they ask what property is this, I don't know about you, but I'm kind of lazy. No, I'm not lazy. I am a conservationist of effort. I'm an energy conservationist. There you go. I write commutative plus or commutative times. The commutative property of multiplication and the commutative property of addition. Okay? Order doesn't matter. 12 plus 13 is the same as 13 plus 12. 5 times 2 is the same as 2 times 5. I have to understand the property because if I don't know that I'm allowed to do that, that's just how math works, then I might not understand the directions and the explanation later on. That's why we start with this. Okay. Commutative property, order doesn't matter. Next one, how many of you have ever heard, especially as teenagers, guilty by association? Wow, okay. I feel incredibly old that all right. Well, like 3 of you? It used to be like the whole class. Guilty by association means I don't care if you pulled the fire alarm. You were with him. You're guilty. Associative property is about who that number or variable is associating with. Grouping. Who's your group? Right? How many of you have probably been told, I don't want you associating with that person? Okay, there go the hands. Okay? Maybe your choice and significant other did not meet with parental approval. Maybe you got into a wee bit of trouble hanging out with that one kid. Okay? Associative, your associations, who you are grouped with. Associative property says it doesn't matter who you're grouped with, grouping does not matter. It's still the same result. Okay? You all know the order of operations, right? I hope. If you don't, in the margins, old school, who remembers? What is the order of operations? Yeah, starts with parentheses. Exponents, okay. You probably heard it as PEMDAS. Please execute my deranged adolescent sister. Okay? There was a kid who said this in years ago, and I don't even remember what I used to say in class. It was too good. I'm just stealing that. Please execute my deranged adolescent sister. They really didn't like their sister. Okay? PEMDAS is the order of operations. This is the way you're supposed to do math. You start by taking care of everything inside the parentheses. Then you do the exponents. You have to take care of exponents before you can do the multiplication, and on and on and on. Before I go any further with any more of these properties, I'm going to give you a little bit of Facebook math here. Facebook math, meaning Grown adults, your parents, your aunts, your uncles, your boss, your grandparents, they will argue with people online about this. They will get into full-blown fights and start throwing around some names. Ready? Actually, let's do 8. What's the answer?
27. Oh wait, no. 6. No.
Figure it out. Argue.
6.
Talk to your neighbors. Argue. Grab a calculator. I don't care.
6.
Figure it out.
18 divided by 9 is 2. That's 36.
18 divided by 2.
Oh, all right. What if I wrote it like this?
That doesn't change.
Oh. It's still 1.5. I remember that from last year. I just don't know where. Like 18 over 18. Wait, hold on.
Come on, argue it up. Convince your neighbors.
Wait. No, it's not. 9 times 3.
6.3. Repeat. 6.3 repeat.
I'm still not hearing a definitive answer from the group. Okay. There are two different ways to do this. One is right, one is wrong. The way that people will get mad about this is they'll say, well, multiplication comes before division, right? If I have to multiply before I divide, then this is 18 divided by 27, which is 2/3, or 0.6 repeating. Someone will say that. Someone else will say, well, no. This thing, that means divide. That means it's like a fraction bar. That's like 18 over 9 times 3. It's a fraction bar. I'm dividing, so I got to do this. Well, that's 9 times 3 is 27, 18 over 27. It's the same thing. Oh, hey, we both got the same answer. We must be right. Both of those are wrong. The answer is 6. Because
18 divided by 9 times 2 is 18.
okay, yeah. 18 divided by 9. We know that that's 2, but why am I doing the division before the multiplication? That's not what PEMDAS says.
Because it's order. If you do it either way, it doesn't matter.
Oh, one of them ends up with 2 times 3. The other ends up with 18 divided by 27. This is why people argue about it on Facebook, because they don't understand the order of operations, and it's going to make y'all mad. Division doesn't exist. Subtraction does not exist. There is no such thing as division or subtraction.
Just negative multiplication.
Oh, okay. You're getting really close to it. You do not subtract 5. You add a negative 5. You do not divide by 9. You multiply by 1/9. Dividing by fractions is easy as pie.
I don't know the rest.
Flip the second and multiply. You heard that in elementary school. Oh yeah, you did. Yeah, you did. Should I go down there, grab like our 6th grade teacher, bring them up here, and say, have you ever said this? And they're going to walk around the room with the rolled up teacher's edition, just smacking the whole lot of you in the head, saying, we went through this for a month. Okay? But yes. So, off to the side, in that margin, if you do not already have PEMDAS with all the symbols here written, I want you to have it there. But I want you to add something to it that not all teachers do. Okay? Not all teachers do this, but they should. Right next to multiply and divide, say left to right. Right next to add and subtract, say left to right. Because there really is no such thing as subtraction. You just add negatives. There really is no such thing as divide. I multiply by reciprocals. The reason we're talking about it right now is because multiplication and addition are algebraic structures. To be a math teacher, the capstone course is abstract algebra and ring theory, topology, where you actually prove why math works. You prove why it works. Just nothing but proof, nonstop. That's all you're doing. You're not actually mathing, you're proving. And I tell you what, I'm the math teacher. I haven't wanted to do anything else since I was 12. Okay? This is what I knew I wanted to do. I hated math in that class for the first time in my life. Everyone hits that point where you think you know it and you just run face first into a wall and you can't math anymore. Everyone does. I did. I sat there staring at chapter 1 for 3.5 months because I did an independent study. They just gave me the book and said, tell us when you're ready for the final. Like, I had to figure out why math works on my own. All of math. And then one day it clicked. You ever seen The Matrix? A couple of you? Yeah. It's like a 20-year-old movie now. It's like Neo getting up off the floor and seeing the numbers running down the wall, stopping bullets. The world just made sense after it snapped into place. I went back and looked at a 3rd grade textbook and saw 5 plus -8 is -3. And I went, dude, I know why now. Not just counting things on a number line. Okay? Multiplication and addition are structures that you can prove work because they have the properties on this page. They have a set of properties and rules that make them work. If you don't know the properties, math does not work. That's why we're going through it. Back to the associative property here, because we had to take a little detour side quest. Who just does the side quests? Like, you don't even follow the main storyline. You just do all the completion on the side. Go find all the packages, right? Okay, side quest. If I do the order of operations on these, 9 plus 7 versus 3 plus 13. But it doesn't matter. Either way, I still end up with 16. I followed the order of operations. I did what was in the parentheses first, but it didn't matter. Next to this, I would like you to write. Grouping doesn't matter. Okay, so commutative property says the order I do it in doesn't matter. Associative says the way I group it doesn't matter. And again, there is associative property of addition and associative property of multiplication. They both have their own. We have to be careful that we distinguish those. when when we abbreviate them, we also want to be careful. I do not want to see your paper say AS plus. Okay? Associative property of addition. Okay? Associative property of multiplication. Please be careful. It kind of is. A little bit. Little bit. Kind of like in Algebra 2 when we go over frequency tables and we hit the category for cumulative frequency tables. We want to be careful how we abbreviate that as well. So, associative property says grouping does not matter. I don't care if you were with this person or that person, you're still in this friend group, you were still in the area, you're guilty. Okay? All right, come on down here. All right. I was doing so good this morning, too. Name, rank, and serial number. What's your name?
Caden. Caden.
Caden. Okay. Caden, what's your name? It's still Caden, right?
Yeah.
Like it didn't change in that 2 seconds? Nope. It's almost like it's your identity.
Yeah.
The identity property means I can do this thing to it and it doesn't change what it is. Case in point, how many of you maybe did a little sprouting over the summer? It happens more with freshmen, but how many of you between last year and now, you saw that friend that you haven't seen all summer and they're like 4 inches taller than they were? Okay? It's still them, right? They are still them. Now, you can get philosophical about it, like, dude, you're not the person I knew anymore. Anakin, you're going down a path I can't follow. Like, nothing like that. It's I can do this thing to it and it doesn't change its identity. There's 2 types of additive or identities. You got the you can call it like this. It's the additive identity. I can add 0 to any number and it doesn't change the number. Right? What's 18 plus 0? Still 18. What's negative 29 plus 0? What's waffles plus 0? Waffles. Okay?
My favorite breakfast.
My boys eat waffles every morning. Like Eggos in our house. Okay, not Eggos. Eggos are for rich people. Ours is great value buttermilk waffles. It's like $2.54 for 2 dozen of them. Okay? It's like 10 cents a piece.
They're so much better.
Okay? Eggos is for rich people. Okay? Whoa, we need to brace the board. Okay? So I can add 0 to any number to keep it that number. I can also multiply anything by 1. If I say I have 1 group of 8, how many do I have? 8. 1 group of 8. If I say I have 1 box of 20, I got 20 things. If I say I have 1 times negative 25, I say I have 1 times 38 pi over 7. 38 pi over 7. Okay? Those are your identities. Identities do not change the thing. Distributive. Y'all remember this one? Some of you might think of it as the rainbow, right? So they're not really showing it here. Oh, there it goes. It just, Frank took forever. The distributive identity says, well, what happens when I start smashing together addition or subtraction? I'll say subtraction. We all know it's a lie. But you know what? This is South Dakota. We're all pretending right now. Look at our room. You have addition or subtraction with multiplication. They're combined. Now, I know if I had 2, a parenthesis, and 6. Y'all know that parentheses, when things are smashed up on parentheses, it means multiply, right? The way that my old teacher said it, he said, whenever you got a number smashed up on on anything, 2 with an X, 2, a parenthesis, and a 7. See how there's no gap in between them? He said, whenever 2 things are smashed together, like rabbits and hormonal teenagers, they multiply. You're going to remember it, aren't you? Okay? Like rabbits and hormonal teenagers, they multiply. So what happens when there's more than one thing in there? Then I have to distribute that to everything. If I said, you know what? I just don't like this table. I just don't like the looks of you. So here's what I'm going to do. I'm going to double all your homework. I'm not just... Arturo, score! I'm not just going to run over here and double Arturo's homework. Like, he just takes one for the team. The rest of the guys, they're like, cool! No. I'm going to double your homework and your homework and your homework and your homework. Everyone gets it. Okay? I distribute that double. So you've probably seen it like this. You seen those arrows, right? I take the 2 times the 6 and the 2 times the 8. I find them both separately and then I can combine them. This is called the distributive property. I distribute the number to everything inside the parentheses. So, that's a whole lot of blathering. That's a lot of talking. I don't like talking. Actually, I take that. My wife would laugh if she heard me say that. I like talking. I don't like only talking. I like us doing. Off to the side here, I want you to pay attention. Vocabulary. That's going to come back. When you look at the end of the section, there's always going to be a section about vocabulary. This is where you come back and look. Word for word, there it is. These are the terms that we just did. Now, let's get down to the nitty-gritty. There's going to be an example, and then one we work through together. Off to the left, everything is already worked out for you. They're showing you the blueprint for how we do these types of problems. Name the property illustrated. Pure and simple, we're just going to look at it and say, which of those ones on that front page does this look like? Look at this side and look at that side. What changed? Did they change the order? Did they change the grouping? Did the value not change? What did they do? Well, 3, 2, 5. 3, 2, 5. The order didn't change. So it can't be what? What was the thing that talked about order mattering? Go back and look at that front page. Be sure. What was the thing on there that said order doesn't matter? The very first one, right? Commutative. So I know it's not that one because the order didn't change. What did change? The parentheses moved over, right? The grouping changed. So I go back to that front page and I say, what on here says grouping doesn't matter? It's the associative property. What were they doing? They were multiplying. Okay, it's the associative property of multiplication. So, Same thing. Come on, Frank. Let's go. What property is this? All right, first of all, I got to make sure they're the same thing. What is 12 plus 17?
29.
You sure? Okay. What's 17 plus 12?
29.
I'm pretty sure, yeah. So these are two things that you add if you don't remember the old school vocabulary. They're called addends. The addends are in a different order, but the sums are equal. So which of those properties on that front page says the orders can be different? The first one, what's the first one called? Commutative property. What were they doing with these numbers? On both sides of the equation, what operation were they using? What symbols between them? What's the thing between the 12 and the 17?
Plus.
They were adding, right? So you say the commutative property of addition. Or you can get lazy and just write commutative plus, commutative property of addition. You have to know what it is. Okay? If you're using the abbreviation, you better be able to say it in real life. All right. We scroll on down, they give me a second example. So they're just telling you, one of the types of problems that you're going to do is, here's some stuff, what property is going on? The other one is going to be, I specifically want you to use this property. Now, they don't go showing those arrows again, but if you want to put those arrows in, they said 3 times 11, they wrote 3 times 11. They said 3 times 4, they wrote 3 times 4. 3 by 11 is 33. 3 by 4 is 12. Add them together, I get 45. Versus on this side, if I were to use the order of operations, 11 plus 4 is 15. 3 by 15 is still 45. So it didn't matter which way I did it, it was still 45. That's why it's a property. That's why it's a rule. That's why it makes math work. So over here, what am I multiplying?
The 5.
The 5, right? It's all hugged up on, it's humping this 12's leg over here. Okay? I'm going to take the 5 times the other stuff. So first I'm going to write 5 times the 12. Then I'm going to write 5 times the 3. I got to write it again because this book likes being redundant. Then I'll simplify both sides and I'll make sure that it actually works. Is this true? Did I do this right? Is this real or does it break math? Well, inside the parentheses, what is 12 plus 3? Get those fingers if you need them. What's 12 plus 3?
15.
15. Anyone off the top of their head without the calculator know what 5 by 15 is?
115.
It's okay. I want you guys to say something. Worst case scenario, you're wrong and we learned something. 75. How many of you just started counting? Just started counting in your head. 5, 10, 15, 20, 25, 30, 35, 40.
10, 20, 30, 50.
Ooh. Say that again and louder.
I did the 5 times 10, and then I did the 5 times 5, and then the 5 times 10.
I did 5 times 10 because there's a 1 in the 10 spot. And then 5 times 5 was 25. 50 plus 25 is 17. Do you know what you just did? You distributed in your head, except you did it with 10 and 5 instead of 12 and 3. You did distribution. Distribution is how we do mental math. What's 5 by 12? 60. 5 by 3 we said was 15. In either case, when I either multiply those or add those, I get 75. Ugh, 75. That's when we moved into our house outside of Bell. 75. We moved in during the 75th rally. And I was driving back and forth on I-90 between Rapid and Bell. And the tire blew on my trailer. It was something. Yep. Don't do that.
It's because we went through 6 tires.
Don't do that.
How do you go through 6 tires?
That's like
Random must have been driving.
Yeah.
that's cartoon levels of dumb. That's like the beginning of Cars. Like what? No, that's a bad decision. That's a really bad decision. Okay. Hey, y'all. I would like you to fill in those blanks. So right above this is 13 times 12. It's this. What's 12 times 13? Write it there. Should be the same thing, right? We're dealing with properties. But then, look at that second sentence. Under both of those, 1 and 2, I want you to write, name the property that they just illustrated. Go back to that first page and tell me, what property does this look like? And when it's time for you to do the problem like this, I don't want you quiet. I don't want this room dead quiet as you all slowly chitter away like a bunch of 1820s accountants. I want you talking to each other. We're set up like the Senate chamber for a reason. Talk to your neighbors. Argue with them. Make sure you got the same thing. What? Yeah. Choices. Yes, they are 156 and 19 respectively. Okay? But the question is, what property is going on? The first one. What did they change? Yo, eyes and ears back up here. I asked you a question. What changed?
The order.
From this side to that side. The order changed. They flip-flopped them. Order changed. Order does not matter with which property. Go back to the front page. And we added the trailer on there. Good job. It's the commutative property of multiplication. You do have to specify that, because commutative multiplication, commutative addition, those are different things. Those are different algebraic structures. They're different universes. Any of you following the whole like Marvel, what if, the alternate timeline, stuff like that? Any of you got that Disney Plus, get that addiction? Like, come on, when's the next episode? When's the next episode? Okay? Multiplication is a different structure than addition. They're just different. So you have to be careful to put that on there. Thank you. What about the next one? 19 times 1 is still 19.
That would be identity property of multiplication.
Identity, because its identity did not change. Multiplication, because I multiplied by 1 to keep that identity. So I can just say identity of multiplication like that. You don't have to write the whole thing out. That's fine. Okay. So one more time. I'm going to walk through it one more time, except now we're talking about that distribution again. Oh, no, this isn't distribution. It's something else. Sorry. You know what? Just ignore all of this and pretend that it's not on your paper right in front of you. Look up here. Without them just walking you through it, what do we think? What's changed?
The change is like the order. Everything is still in the brackets like the way it was originally. They just put the 14 on the
Oh, that is sneaky. That is sneaky because what has every problem we've done so far been that involved parentheses? They were all associative, right? But look at it this way. You know what? Let's go PlayStation on it. You're like, huh? What? What if I said, would you agree that what's in the red box is in the red box?
Yes.
What's in the blue oval is in the blue oval?
Yes.
Because it's too big to make the circle. What is that property? What did I do? You just changed the order, right? If those would have just been two numbers, you would have been like, oh yeah, it's commutative. Duh, look at it. But because they threw parentheses in there, that's like curveball. They're trying to mess with you by putting three things in parentheses in there. That's a very good catch. It was still 16 and 11. It was still 16 and 11. So, yeah, nice catch. Before we even got down here. Okay? Now, verify that they're the same. So we actually want to go through here and do the work to make sure they are the same. So,
Would that be distributive then?
that's when you multiply into addition subtraction problems.
So then it's
When you combine multiplication and addition together.
so it is associative.
No, this is commutative. You said commutative, right?
Originally.
Yeah, it's commutative. Okay? I'm taking 14 plus thing. I'm taking thing plus 14. It's still commutative property. What is 16 plus 11?
27.
And as soon as I take care of what's in those parentheses, now do you see commutative? If you didn't see it before? 14 plus 27 is 27 plus 14. Oh, they just flipped it. Add those two together. Almost the meaning of life, 41. And you're going to say the addends. Again, addends are things that you add together. Addends are grouped the same way, but the order has changed. That is the commutative property of addition. And I'm going to write it like that because I'm an energy conservationist. Okay? So down below this, you got a little more practice. Do you know these properties? Those four, get them. Argue it out with your neighbors. Keep flipping back to that front page. Y'all, you're just going to have to do it again another time. If you're just not in it today, I understand. It happens. Make sure you come back to that video and get it done. Because this is the kind of stuff that's randomly going to pop up on a review item of a quiz next April. Okay? We will keep bringing this stuff back up. So please, even if you're not feeling it now, you got to take care of it at some point. Better to just get it done now if you can. All right, I got to ask. Original design, or are you a fan of Nicol Bolas?
I just kind of based it off of that guy. Yeah.
Oh, he's like the 20,000-year-old dragon overlord who lost his godhood and is going to sacrifice the sparks of all the planeswalkers of the multiverse.
Yeah.
Oh, look up War of the Spark trailer on YouTube. The video is awesome. They did this really creepy acoustic background song of In the End from Linkin Park in the background. All the while there's like zombies going everywhere and this dragon just... The art direction for that set was amazing. No! However, if you ever need to come in here and just grab that because it's going to help you focus in another class, cool. Oh no. That's not good.
No, it's not.
That's really not the flarp.
Not the floor part.
Not the flarp.
That stuff is so loud.
Yeah. Spartan time yesterday, one of my seniors was in here just going...
God, that sounds like brother.
That sounds like we're already done. You guys are doing this pretty good here. They asked the question, did the order change? Yup. So, what property is that?
Plus.
And we do have to say commutative property of addition because we have to specify that. Okay, next up. You know what? Before even theirs, did the order change? I'm going to ask, did the order change?
Yes.
814. 814. The order didn't change, but did the grouping change?
Yes.
Yes, they moved the parentheses. So we say which property changes grouping? Go back to the front page. Which property? Associative. Please appropriately abbreviate associative property of addition. Next it says to use the distributive property. So they just want you to do the thing. What is 2 times 12? What is 2 times 4? And what is 24 plus 8? I heard it. 32. Loud and proud. 6 times 1. What property is that by itself? If it was just 6 times 1 is 6, what property is that?
That is going to be identity.
Identity of multiplication, yes sir. 6 by 10. 6 plus 60 is order 66. How does Emperor Palpatine order pizzas? He orders 66. Okay. Y'all are youngins. You grew up on the prequel trilogy. Okay. Is there anyone here who has never watched Star Wars? Ouch. Dude. Hurts me. Hurts me deep. Nah, you good. Y'all are too young to remember. The original manuscripts for episodes 4, 5, and 6, the old Star Wars movies from the 70s and 80s, the original novelizations of the scripts, the Clone Wars were supposed to be a galaxy-wide civil war between clone troopers and their populations. Blood and guts everywhere. But they couldn't turn that into a PG movie, so George Lucas retconned his own canon and said, let's just have Jedis fighting robots. Like, it was supposed to be blood and guts mayhem because the clone troopers, they all went crazy. Like, they all just went completely off their rockers and started killing everyone.
They should make that as a radio.
It is addressed in the trilogy Heir to the Force, the original Star Wars Expanded Universe novels, where they create new clone armies by replacing the Force around them so they don't go crazy. I'm a geek, y'all. I have 175 or 178 of the Star Wars novels. Like, 380 pages of just geek greatness. So if you ever want to come talk to me about that in game club, lunch, anything like that, oh yeah. Okay, flip it over. One last time. Now they're going to talk about, boy, this does not look good on inverted colors. I'm hearing like D12 here. No one's a D12 fan here. Purple pills, really bad for school. Don't do that. It's supposed to be marbles. It's a bag of marbles. That doesn't look like a bag of marbles. That looks like a scavenger party. Okay. Brittany sold 4 bags of marbles that had 12 in each. Don sold 12 that had 4 each. Hey! I'm a dad. I can do this. I will take those and put those on top of the fridge, and you won't get them back. Come on, lock it in. Okay. Brittany, 4 bags, 12 marbles each. What should I write down here? 4 bags, 12 marbles each. If I have 4 groups of 12, what is that altogether? 48, yes. Y'all can always grab a calculator. You do not have to do things in your head in here. Okay? Use your phone as the calculator. Just make sure you're locked in on what we're doing. Okay? Dawn, on the other hand, says, instead of me selling these big things, I'm just going to sell a lot of little things. Dawn's going to sell 12 separate bags of only 4 marbles apiece. But that's 48 anyway. 48 is 48. What type of property is that? What says 12 by 4 is 4 by 12? Commutative of multiplication. So it turns out the word problem isn't even really a word problem. It was just trying to show you, hey, look, this happens in other contexts. Okay? Meaning, could I, running game club, could I hand out 50 packs of cards that each have 90 cards in them? Or could I hand out 90 packs of cards that each have 50 in them? It's the same amount of cards, but then I start thinking about which one is going to get me more engagement, which one's going to make kids happier, that kind of stuff. I don't know if any of you remember last year around our holiday break, we were giving out free cards, just like boxes of cards, and I had this conga line of kids come running down here from the lunchroom, and they were all grabbing boxes of cards. Okay? Oh, you think that? I gave away my entire stash. That is all just cards. We got something like 30, 40,000 cards donated to us just this summer. Okay? This is what happens when you put game club stuff on Twitter, and then other geeks and adults see that and they're like, oh, hey, that's a really cool thing you're doing there. Here, have this free stuff. So, yep. But, y'all see down here where it says skills, concepts, and problem solving. There's a couple of problems. It says go on. You flip it over. Tell me what property this is. A word problem, a lot like the one we just did. And then vocabulary. Remember when I said vocabulary? You go right back to that front page where it says vocabulary. That's your assignment. Take a look at the clock. Not that clock, it's wrong. It is currently 1:21. That means you have 24 minutes in class to get through number 26. That's it. That is your lesson and assignment, one shot in class. If you finish that, you have no homework. Welcome to Sullivan's class. This is how we do it in here. We're done. Now you get to work on your stuff. And now that you're going to work on your stuff, now if you want to get those jams in, go for it. But remember, if you don't get this done because you're too busy screwing around with your playlist or you got distracted by the 150 notifications that are on your phone, then it's homework. But if you get it done during the time you have right now, then you have no homework. So,
tissue is supposed to be soy sauce.
I see that.
Yeah.
There's Kleenex back there, but I would say because it's going to be sticky, ask one of the ladies to go get you a bunch of paper towels, some of them wet.
Get Clark's wipes.
That's a good question. Here, let me turn off the stream first.